Hello everyone, myself Srivalli, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology. Today, the overview of presentation includes introduction to normal forms, what is meant by DNF, and also we'll see few examples of the DNF. So first, what is meant by a normal form? So before going to discuss about what is meant by normal form, first let us understand why we need to go for this normal forms. So basically, we have seen in the last sessions how to construct the truth tables. So the construction of the truth table, it involves finite number of steps. So whenever you are constructing the truth table, it involves finite number of steps. But the construction may not be practical if number of variables are more. Means if you have only 2 variables, you will get the 4 combinations. If you have 3 variables, you will get the 8 combinations. But if you have the 4 variables, you will be getting 2 power 4 is equal to total 16 combinations. So if you have 2 power 5, you will get the 32 combinations. Means here, the construction of the truth table may not be practical if you have the more number of the variables. Means we can able to do it. It also involves finite number of steps only, but little bit more. So to reduce that, we are reducing the given statement formula into a normal form. So here, let us see the definition of the normal form. Method of representing a simple propositional expression is called a normal form. Means representing the given statement formula to a simple propositional expression, we'll call it as a normal formula. So here, what is this normal form here? So method of representing this to a reduced form, we can also call this method of representing this reduced form, we call normal form. Now this normal form can be expressed in 4 ways. We can represent this normal form in 4 ways. Any well-formed formula, we already discussed in the last class what is meant by a well-formed formula. So here, this well-formed formula can be reduced to any of these 4 normal forms. What are those here? What is disjunctive normal form, conjunctive normal form, principal disjunctive normal form, and also principal conjunctive normal form. So here, disjunctive normal form, we can also call it as DNF. Conjunctive normal form, we can also call it as CNF. Principal disjunctive normal form, we can also write it as here PDNF. We can also call this as PDNF. Principal conjunctive normal form, we can also call it as PCNF. Means any statement formula which is called a well-formed formula can be expressed in any of these 4 normal forms, either in DNF, CNF, PDNF or PCNF. Now let us see one by one along with the examples. And before going to discuss about the first normal form which is called DNF, so let us understand here, for our convenience, we are going to remember here, product is nothing but conjunction. Sum is nothing but disjunction. So we have to remember this. So here conjunction means always it is a product. Disjunction means always it is a sum. So just for our convenience to solve the other problems of all these 4 normal forms, you need to remember here product is nothing but conjunction. Here disjunction is nothing but here sum. So, and also before going to discuss about the first normal form which is called as here DNF, we have to remember some basic terminologies also. And those terminologies are elementary product here. So here what is meant by elementary product, and we also have elementary sum. So what is meant by this elementary product and elementary sum? So here first one, elementary product. So a product of the statement variables and their negations in the formula is called an elementary product. So here a product of the variables and their negations. So here what is meant by a product? So just now we have remembered, we already discussed that you have to remember product means conjunction, sum means disjunction. So here a product of the variable and their negations. So always you have to remember product is nothing but conjunction, and the representation of the product is here AND. So the product of the statement variables and their negation, this is the symbol of negation in the formula is called an elementary product. So what are the possible elementary products here? Means if the product of the variables and their negation is called elementary product, what are the representation of this elementary products? For example, let us suppose here I am considering two variables p comma q. The product means here we can write this p comma q as p and q is one combination, p and negation q is one combination, p and negation q is one combination, negation p and q is another combination. So not only this, along with this, only one single p, only one single q, and not only that, here p and q and negation q, p and negation p and q. So these are all called elementary products. So that is nothing but here. So the product of the variables, product means always we need to remember that conjunction symbol. The product of the variables and also their negation, we can call it as an elementary product. Means these are all the possible combinations of this elementary product. So that is what we have here. The possible elementary products are only single p, q, negation p and q, negation q and p, p and negation p, q and negation q, p and negation p and q. So these are all called elementary products here which are possible for this elementary products. So next let us understand what is meant by elementary sum. So here a sum of the two statement variables and their negations is called elementary sum. So in the previous slide we have discussed about elementary product. Product means and here. So in between the two variables we are applying this and we are seeing some possible combinations. And here elementary sum. Sum means here or. So here sum means or. So a sum of the two variables and their negations is called elementary sum. So the possible elementary sums are p comma q, negation p or q, negation q or p, p or negation p, p or q. So that is nothing but here if you are considering two variables p, q, so one single p is also called elementary sum, one single q is also called elementary sum. Not only this, p or q is an elementary sum, negation p or q is an elementary sum, p or negation q is an elementary sum, negation p or negation q is also an elementary sum. Along with this here, negation p or q or negation q or negation p or q. So or we can also write p or negation p, q or negation q. So these are all called elementary sums. Means in between the variables we are applying the disjunction. Means sum. We can also pronounce it as here this is a sum. So these are the two basic terminologies. Before going to discuss about the normal forms, we need to remember that too. Before going to discuss about the DNF problems and CNF problems, we need to understand what is an elementary product and also what is an elementary sum. So next let us understand the normal form. First normal form, that is disjunctive normal form. So what is meant by disjunctive normal form? See here, this disjunctive normal form we can also pronounce it as here DNF. So here a statement formula which is equivalent to the given formula and which consists of sum of elementary products is called disjunctive normal form. So here the statement formula means it can be a well-formed formula which is equivalent to the given formula. Means they will be giving one statement formula and you have to solve until you get one formula, and that formula consists of sum of elementary products. So here sum of elementary products. So previous class we have discussed about laws of logic. So laws of logic means we have some formulas and we also have some standard formulas that also we need to remember, And if you consider one statement formula and you need to solve to the given formula, and that given formula should be in the form of sum of elementary products. And how to solve that sum of elementary products here? By using the laws of logic. Means you need to apply that laws of logic and also statement formulas to get the sum of elementary products here. And this sum of elementary products, we can call it as disjunctive normal form. So here, sum of elementary products. So we already discussed what is an elementary product. So elementary product means and we have all the possible combinations. We have seen here P and Q, P and negation Q, like that. But sum of elementary products means here this is one elementary product and one more elementary product, for example P and Q. In between you have to get sum. Sum is nothing but OR. So this is sum of elementary products. So this is called sum and these two are called elementary products. Means you have to get this one by taking the statement formula and by considering the laws of logic. You need to get the result in the form of sum of elementary products. This is called disjunctive normal form. So this is the definition here. A statement formula which is equivalent to the given formula and consists of sum of elementary products here is called a disjunctive normal form of the given formula. So here we have the formula also here. Elementary product or elementary product. That is what here. Elementary product means what? P and negation Q, negation P and Q, P and Q, P and negation Q, something here which is in the form of the products here. But in between you should have OR. So this formula you need to get it at the end, the result. Next here, let us see the examples on this DNF problems. So here we have seen what is an elementary product, what is an elementary sum, and we have already seen the definition of the DNF also. Now let us solve few problems based on the DNF so that we can understand very clearly how to solve the normal form problems DNF. So what is the first one here? Obtain DNF of P and P implies Q. So here we have the question, we need to get the DNF. Obtain. So we need to remember the question also very clearly here. So DNF, obtain DNF means what is meant by DNF here? Sum of elementary products. So here sum of elementary products means what here? You have sum and all the sides here you should have elementary product. It is not mandatory that you have to get only two elementary products. Even you can have the other elementary products also. But always in the middle you have to get sum and all the sides you should have the elementary products. This is the formula, you need to get it here. So the question is, you need to get the sum of elementary products for the given statement formula, that is P and P implies Q. So write down the given P and P implies Q. This is the formula, statement formula given here. Now P and P implies Q. So you need to solve this by using the laws of logic until you get into the form of the structure sum of elementary products. So here P I cannot write it anything. Why? Because here I don't have any formula here. By using the laws of logic I am writing as it is. P implies Q. So from the standard formula we have P implies Q is equal to negation P or Q. So write down as it is here, negation P or Q. So if we observe in this row, here I didn't get still sum of elementary products. Here I have this elementary product, but this is not in the form of elementary product. And here this is not sum, I have and here. This is not elementary product, that is here, this is a sum here. So still I need to solve it here. So here how to solve this one is here. So as I have P and negation P or Q, so just apply the distributive formula here. So just consider this is P and this consider Q. Negation P and considering it as Q or. So what is the formula here I can get by applying the distributive formula? I can get here P and Q or P and R. So, if we observe this formula here, the result you are getting, the RHS you are getting in the form of sum of elementary products, so that I can apply here. So, write P and negation P. Here Q is nothing but negation P. Q is here R. So, P and negation P or P and R. R is nothing but here Q. So, here if we observe P and negation P or Q. So, P and negation P here I am writing or P and Q. So, now if we observe this, it is in the form of sum of elementary products here. So, this in the middle you have the sum and both sides we are having the elementary product. So, sum of elementary products, which is nothing but this is the required DNF. So, here it is a required DNF. So, this is the problem. You have to solve it here to obtain the DNF. So, like this we need to solve the DNF problems. So, now let us see the another question also. Let us see one more example here. We have P implies Q and Q implies P. So, here note down given here P implies Q and Q implies P. So, here by applying the standard formula you can write negation P or Q and negation Q or P. So, here I am just writing in place of P implies Q as negation P or Q. Q implies as negation Q or P. Why? Because we have the standard formula here. P implies Q is equivalent to negation P or Q. Okay. So, next here, if you observe this, it is not in the form of DNF. Means sum of elementary products. So, this is not a sum here. This is a product. By this only we can decide that this is not a DNF here. Then it is necessary to convert this formula again into sum of elementary products. How we can consider, and how we can convert this into DNF here. So, I have 4 variables. If you observe carefully here, I have 2 variables and here I have 2 variables. Altogether we have 4 variables, but for the distributive formula, P or Q and R is equivalent to P or Q and R, P or R. Or else P and Q or R is equivalent to P and Q or P and R. Out of these 2 formulas, the second one we can able to apply this to get the required DNF sum of elementary products. So, if we observe, this is negation P or Q and this is and here we have negation Q or P. So, which one I have to consider as P, which one I have to consider as Q and R. So, let us suppose here, if I consider, I don't know anything here, how to apply, which one I have to consider P, Q, R. So, let us suppose here, I am considering P or Q and R. So, if I have like this, means if I consider this total negation Q or P, will I get the required DNF or not? Will I get into the form of sum of elementary products or not? That we need to check. So, P or Q and R is equivalent to, so if I write here by applying the distributive formula, P and R or Q and R. So, this is also one distributive formula here. So, where I have considered here P, Q and this third one I have considered as R. So, P or Q and R is P and R or Q and R. So, here I am getting sum of elementary products. So, I can proceed with this formula also. Not only these 2 formulas here, we can also proceed like this here. So, if I apply like this, so P is, here P and R means what is P here? Negation P and R is here negation Q or P. So next, or Q and negation Q or P. So here if we observe again, we have different connectives in both. So I got some in the middle, but in between I didn't get here elementary products. So what are elementary products here? P and Q, or we can have P and Q and negation Q. P and negation P and Q. Means you can have three variables also, but you should have always product in the elementary product. But if we observe here, we have and here we have or. This is not an elementary product. Still there is a need to convert that into elementary product here. So again apply distributive formula as we have different connectives here. So then what you will get here? Negation P and negation Q, or negation P and P. This one I am converting like this. Or again here also same thing we are applying. Apply distributive law Q and negation Q, or Q and P. So here if we observe, all middle we have the sum, and these are called elementary products. So if you want, you can stop up to here. But you can proceed with other statement formulas if any necessary here. So if we observe P and negation P, or negation P and P. So negation P and P, in the laws of logic we have the formula which is called as F. And this one as it is you can write it is here negation P and negation Q, or F. So in the same way, or Q and negation Q is here F, or Q and P. So F or P, mean this total I am considering it as P. F or P is P. Here also F or P is P. Then what is the answer you will get here? The final answer is negation P and negation Q, or Q and P. So this F is not there. Why? Because by applying the formula F or P is P, you will get only negation P and negation Q. And here by applying the formula F or P, you will get only Q and P. So now if we observe here, this is called a sum, and these are called elementary products. These are called elementary products. Now sum of elementary products. So as we get the resultant as in the form of sum of elementary products, which is nothing but DNF, then we can stop our problem here. So this is like how you need to solve the DNF problems. So here DNF means sum of elementary products. So first you need to understand, if you want to solve all DNF problems, first you need to understand what is an elementary product, what is an elementary sum, the representation of product and sum also. Then you can able to solve it. So this is like how you need to solve all the DNF problems. So here what we have discussed in our today's session is what is meant by normal form, what is the need of the normal form to discuss here. Why? Because as we have discussed in the last sessions about the truth tables, why we are again switching over to the normal forms. What is the need of the normal forms we have discussed. What is the definition of the normal forms we have discussed. What is the total types of the normal forms like DNF, CNF, PDNF and PCNF. Types of normal forms we have discussed here. Out of that we have discussed what is the first normal form. We have seen the statement formula, that is what is the definition of the DNF, and we have already seen here the examples of the DNF problems also. So by this we'll end the session for today. In the next session we'll discuss about what is meant by CNF and we'll solve few examples of CNF also. Thank you everyone.